Welcome to video 3 in our series of 6 videos on non-contact cube decisions. We'll be looking at stacks and gaps and start to develop a feel for how much these weaknesses affect our cube decisions. We will introduce the keys count, and then we will finish with some examples of the 8, 9, 12 rule with the stacks and gaps factored in. When we talk about stacks and gaps, we're talking about distribution. To have an efficient bear-off with the best winning chances, we are looking for a formation that has these characteristics. No gaps, no excess stacking, more checkers on the 6, 5, and 4 points compared to the lower points. And if we do have some stacking, it is always best to have the stacking on the highest points rather on the lowest points. And if we do have some gaps, it's best to have the gaps on the lower points instead of on the higher points. Let's quickly look at how much stacking can change our winning percentage. We will use this formation for both sides, and we are not focused on if this is a cube or not. We are looking to develop a feel for how changes in distribution affects our winning percentages. Now in this position, we are on turn. And as is, our winning percentage for this position is 63%. Now if we create some stacks without changing the pip count, +1, -1, our winning percentage, we now have a weakness, our winning percentage drops to 58.9%. We lost 4% in winning percentage just by having this weakness. What if instead of for us, our opponent has this weakness? Now our winning percentage increases to 66.8%, almost 4% increase, and we're looking at just about an 8% swing in winning percentage just based off of if we or our opponent has this weakness. Now I'll quickly go through a few more of these, and then we'll go back and we'll do the same thing, but instead of looking at stacks, we will look at gaps. I'm going to go through these quickly, but then we're going to go back and review so we can learn more about our little experiment and these numbers that we've generated. So the second one we're doing here, we're going to use this position. As is, our winning percentage here is 63.9%. And if we create some stacks, a weakness for us, our winning percentage drops to 58.4. We lose 5.5 winning percentage in winning percentage with this weakness. And if instead of for us, the weakness is on the opponent's side, we gain 4% in winning percentage. The next position. In this position, as is, our winning percentage is 65.5%. If we have a weakness with some gaps, some stacks rather, we lose almost 3.5% in winning percentage. And if that weakness is on the opponent's side of the board, we gain just about 2.5% in winning percentage. And one more that we're going to look at for stacks. As is, this position wins 66.9%. If we have some stacks, our winning percentage drops by about 5%. And if instead of us, that weakness is in the opponent's position, we gain 3% in winning percentage. So those are quick examples for stacks. Let's look at gaps. Quick look at a couple of positions that have a gap. If this is our position, as is, our winning percentage, 63.8%. Again, we're not going to change the pip count. We're just going to create a gap. And this gap is a big weakness. We lose over 8% winning percentage with this gap. If instead of us, that gap is on the opponent's side of the board, we pick up 7% winning percentage just because of that weakness. Our next one, in this position, as is, our winning percentage, 63.3%. If we have a gap without changing the pip count, we lose again almost 8% in winning percentage. And if instead that weakness is on the opponent's side, we gain almost 7% winning percentage. In our next position, our winning percentage here, about 63%. And if we have a gap, without changing the pip count, we lose 3.5% in our winning percentage. And if we're fortunate enough that our opponent has the weakness, we gain 3.5% winning percentage. In our last position, in this position again, we win about 63% as is. If we have a gap, we lose about 4.5%. And if instead of us, it's our opponent that has the weakness of a gap, we gain about 4.5%. So those are our numbers. Let's review and see what we've done. So here's a review of what we just learned. When we introduce a stack to either side, we saw about the 3, 4, 5% swing in winning percentage. And if it's one side or the other, up to a 10% swing in winning percentage. But when we introduced a gap, we saw very large swings in the winning percentage. And notice, when we first started talking about this, you want more spares on your higher points. If you're going to have any stacks, you want them on your higher points. The gaps that we put into our higher points up here had the biggest effect on our winning percentage. So, some of you may have noticed something very important. Our 8-9-12 rule is a percentage rule. It's based off of two numbers. We have our pip count, it gives us our pip lead after we count both sides, and these are the only two numbers. Now when we take a position like this, we can get a pip lead percentage. If we add one, subtract one, we didn't change any of these numbers. We didn't change the pip lead, and we didn't change the pip count. And if we didn't change either of these, that means this stayed exactly the same. And that's a problem, because we're getting the same number, but just a small change in distribution is giving us a different answer up here. And when we change our winning percentage by that much, you can get a different answer. Maybe it's a cube, maybe it's not with these stacks, and that's also going to change if it's a double or a take, if it's a take or drop. So we need to start to factor in our stacks and our gaps. This is a very important thing to do, because the 8-9-12 rule is, there's nothing built into the 8-9-12 rule, it's factoring in distribution. Now at the end of this video, I will be going over examples of how you can start to do that, and that's a very important thing to do, but this is a perfect time to introduce the Keith count. Quick introduction to the Keith count. Now it should make sense that if you're a top backgammon player and you start to develop tools like this, you learn about this, but then you notice this phenomena, that the stacks and gaps are making a huge difference in your winning percentage. And that has to be factored in, and you would ask, I wonder if we can come up with something that would already take into effect the stacks and the gaps and give us an answer directly. Now, of these systems that was developed, the Keith count was one of the best, outperformed the other systems in almost every position, and personally I think it's the easiest to use. So in the next 3 videos, I will be showing you the Keith count. It sounds a little intimidating that it takes 3 videos to show you the Keith count. What I found is that, from personal experience and watching other players, the Keith count's actually pretty easy. But since you don't use it every single game, you're not practicing it on a regular basis, but it's there. And you do use it very often, but not often enough that you remember it. So what happens is someone will learn the Keith count, then a couple days later, a week later, they'll get a position, they should be using the Keith count, and they don't remember the simple rules that are the Keith count, and so then they don't apply it. And if you're learning something and you don't remember it, then why are you taking the time to learn it? So the breaking up of the keys count into 3 videos just makes it easier. It's going to make it a lot more fun as well, instead of just memorizing a list of rules. So that's why it's 3 videos. That'll be in the next videos. This is just a short intro into the videos. So we have our information. This should make sense. What does the keys count do? The keys count is going to penalize you for stacks, and it's going to penalize you for gaps. It's going to penalize you for the stacks, just like we saw at the start of this video, the suggestions. It's going to penalize you for stacks more on the lower points. It's not going to penalize you for stacks on the higher points. The keys count is going to penalize you for gaps on the higher points. And you can see the bias here from the higher points to the lower points. The keys count is taking into effect the stacks, it's taking into effect the gaps, and it's taking into effect the location of those gaps, be they higher or lower, the location of the stacks, be they higher or lower. So what do I use? I actually use both. Now with the keys count, one of the things that you have is it starts with a pip count. It's just like the 8, 9, 12 rule, which is really handy. The pip count gives us our race lead, and then what I do is I simply look at the distribution of the checkers, and at this point, because I know both, I can use either the 8, 9, 12 rule or the keys count. If there's even distribution, I use the 8, 9, 12 rule. If there's a lot of stacks and gaps, then I'll use the keys count. If I do my count, and the math on the 8, 9, 12 rule is super easy, and I get a nice even number, almost no math at all, like some of them they just jump out at you, then I will make an adjustment based on my distribution, and if I'm confident with that answer, I'll just go with it. But it's nice at this point, when you've done your quick pip count and you're about to make a decision, you have 2 tools to go to, and you know exactly when one of them is going to be either faster or more effective for you. So that's a quick introduction into the keys count. It is good to know both, and with 3 videos following teaching you the keys count will be very easy to learn instead of just looking it up and trying to memorize a list of rules. So that's going to wrap up this part of the video. We're going to finish this video with some examples of the 8, 9, 12 rule and show stacks and gaps, and we're going to make some adjustments and see how that goes. 12 quick positions. We're going to look at the 8, 9, 12 rule, and we're going to make some adjustments with our stacks and our gaps. This is our first position. We have our 8, 9, 12 rule at 5.3% after we do the pip count and do the quick percentage, which puts us at a no double. Our distribution is almost perfect. We have this extra checker on the 1, which we don't like. And I like to call points with 1 checker a half gap. We really don't factor that into the keys count, but it is good to have that in the back of your mind. So our opponent's distribution looks terrible. They have these extra checkers, and as soon as they roll a 5, this is going to be a gap. So we're at 5.3%. Does our near perfect distribution and our opponent's bad distribution overcome? And this actually turns out to be a double take. It does. So we're able to make an adjustment based off visually what we see in the position and where our opponent's weaknesses are. This is our second position. If we do our count, we'll find that our 8, 9, 12 rule is at 2%, pretty far down. We have close to perfect distribution here, and our opponent has this big gap on the 5 point. The stacks we have here are smaller than our opponent's. So we have a pretty big jump here. Is this enough to make this a double take for us? And the actual answer is yes, just barely. This gets us just to the edge of a double take. So this is being able to look at the position and look at as many of these as you can over time and develop a feel for this. We're already starting to learn that the gap on the 5 point is a very bad thing, and we're able to make a pretty big jump and possibly find a cube in this position. Our third position. Now our opponent's on turn in this position. So doing the math real quickly, 8-9-12 rule, we're at 13%. Double pass. So if based on the rule, if our opponent cubes us, we should pass. We have two checkers down here which are not good, but our opponent has 3. Other than that, the position is somewhat balanced. They're a little better up here than we are, but they have an extra checker down here. And our gaps, our potential gaps, are low, so they don't count for too much, but those are equal. Is this extra checker down here and that little bit of distribution on top, the difference here, is this enough to move the answer in either direction? So right now we're at a double pass. The actual answer is that it's a double take. So we've moved pretty far into the take here, where that actual number would be if we were able to adjust this exactly. We don't know, we don't need to know. We're just looking at our position, and this extra checker, did you think it was that much of a problem for our opponent? And it went from a double pass to a very solid double take for us, because we're starting to learn how to factor these things in. Position number 4. We're on roll. Do a quick count, and our 8-9-12 rule has us at 4.5%. Not really close to 8. Looking at the position though, we do know that extra checkers on low points are not good. Our opponent has 1 extra checker than we do, so we both have this weakness, but it's even worse for our opponent, and they have 2 gaps where we only have 1 gap. Now it is on the lower end of the board, so it's not going to penalize us as much, but 2 gaps versus 1 gap, 1 extra checker low, is this enough to overcome and get us to a double take? The actual answer for this one is double take. Double take by 85. So this is pretty solid into the double take range, and a full blunder if we don't double this. So again, 1 extra checker on the low numbers here, and the low pips, can make a big difference in the position. This is a double take. Position number 5, our opponent's on roll, thinking about cubing us. They're looking pretty good. The 8-9-12 rule, they have at 15.4 for our opponent, so that's a pretty strong cube here. Double pass by the rule. And 15.4, that's comfortably above 12. But our distribution is perfect. It's just about as perfect as you could hope for. Our opponent has this gap on a 4-point, which is very bad, and these half gaps. As soon as the opponent rolls a 2 or 3, that's going to be another gap for them, which is a problem, and this extra checker on the 1 point. In our first few examples, we saw just the extra checker down low can make a big difference. Is this enough to move this where we can take this position? And the actual answer is yes. 57. So we're moving to an area where dropping this is going to be a blunder. So now we're able to move into the double take range based off our read on the position, our distribution near perfect, and the opponent has multiple problems in his board. This is a double take. Our 6th position, we have this position where we are on roll, thinking about keeping our opponent, but our distribution is pretty bad. The 8-9-12 rule has us at 9.3%. So we're in the double take range, but not in a really big way. The gap on a 5-point is bad, and we have a whole host of checkers down here where they shouldn't be. And we have a few checkers up on top here, on bottom for our opponent, that are not good. But our opponent's distribution is near perfect. So, does our weakness move us to a no double? And the actual answer is yes, in a big way. This is more than a blunder to double this position. We have to make a large adjustment because our distribution is so bad in this position. We're going to wait and not cube this position. Position number 7, our opponent's on roll considering the cube. 8-9-12 rule has it at 14. This is a strong double pass, just based off of the numbers. But our opponent's distribution is pretty bad. Ours is near perfect. We have a gap on the 5 point for our opponent and a half gap on the 4 point, and we got some extra checkers on the low points where he'd rather not have them. So I think we can make the adjustment pretty easy to take this cube. It's in the double pass range, but our opponent's distribution is really bad. How bad is it? The actual answer is that it is a double take. Our opponent can't cube this, but look, we went from double pass all the way down here. The double is only a 28 for our opponent. So this is close. This is very close to a borderline double, almost starting to move into the no double range. So this one, it's good to remember just how far we can move because the distribution is bad for one side and near perfect for the opponent. Position number 8, we are on roll, thinking about cubing our opponent. Our distribution is perfect. Our opponent's distribution is not bad. Gap here, but the gaps are low. Distribution is right where it should be. 8-9-12 rule has us at 6.4%. So, are we good enough to cube this? Again, our opponent, it's not bad. A gap is still a gap, and even though we're not counting the gaps on the low points too much in the negative, it's still a gap. If the opponent rolls a 3 on their roll, they're only going to be able to pull one checker off because the 3 is not going to pull a checker off. So let's see how much of a difference this made. It's a double take, but only by 32. So it's a solid double, but nothing crazy. So we are able to make an adjustment in this position because our distribution is better than our opponent, even though it's not an overwhelmingly difference. So double by 32, very easy take for our opponent. Position 9, again, we are on roll, looking at a cube here. We have checkers on these low points we're not too happy about, but our opponent also does. They have 2 gaps versus our gap and half, and the 8-9-12 rule has us at 4.5%. So pretty far away from 8 rather. Is this enough? Is the extra gap enough to make this a cube? And this one, kind of visually it looks close because we have similar disadvantages in our position, but there is an extra gap. Let's see if this is enough. And it is, just barely. This is a double take by 5, super easy take for our opponent. But we went from a no double to a borderline double. And doing this live, does this look like that? Does it look like there's just enough to move our decision to where it's a borderline double? Next position, we are on roll, looking at cubing our opponent. We have a great position. The 8-9-12 rule has us at 2%, so we're way on the low end. But we have a near perfect distribution, and our opponent's got some major problems. These 2 extra checkers on the 1 point really jump out at us. This gap on the 4 point is bad. Any 3, and the opponent's going to have 3 gaps to contend with. That's a pretty big jump, but we have basically nothing wrong with our position, and our opponent has multiple things wrong with our position. This turns out to be a double take. 60. Closing in on 80, this is a blunder if we don't find this cube. And again, this is just not an exact science, but we have our 8-9-12 rule. Seems like we're pretty far away, but our perfect distribution versus our opponent's board, we have to start learning to see that we can move our arrow into the double take window when we have positions like this. Our next position, our opponent, is thinking of cubing us. They have reasonable distribution, but some extra checkers on the low points. We also have extra checkers on the low points, a gap, and some bad distribution on top. Also, there's fewer checkers on the board, so their cube is going to be a little stronger. Now the 8-9-12 rule here has them at 11.4%. We're closing in on double pass territory. Is their distribution better than ours by enough to make this a pass? The actual answer is yes. Now it's a pass by 25, so it's not a big adjustment, but being able to see this visually, we have the gap on the 4-point, which is bad. Our stack is higher than our opponent's stack, and the only real disadvantage the opponent has here is the extra checkers on the low point, which we also have. So we're able to move our arrow just a little bit into the double pass window because our opponent's better. Our last position we'll be looking at, we were looking at cubing our opponent. We do our count, and the 8-9-12 rule has us at 11.1. Very strong cube based off of the numbers. But our distribution is bad. It's not super bad visually, but remember in our first few, we saw a pretty big jump when we had extra checkers on the 1-point. So we have 2 solid gaps in the weaker part of the board, so that's not too big of a problem. Our opponent has 1 and 2 half gaps, but again, it's on the weaker point, not as bad as having them up on top. The opponent's distribution is better on top than ours, and these points versus our opponents are a little weaker. But these 2 checkers down here, is this enough to move the arrow all the way to a no double? And it turns out that it is, only just barely, 23, so it's not too far away. If you made this cube, it wouldn't be a very large error, but learning that we can move that arrow pretty far when we have extra checkers on the 1-point is very important. So this position, kind of a borderline double, but it's a no double, very easy take for the opponent. So what have we learned in this video? We've learned about the stacks and the gaps. Visually, we have to start seeing these things right away and know that we're going to factor them in. Now, some of you may have been surprised by how much of a difference these extra checkers make on the 1-point. And the takeaway from this is that this is not an exact science where we're making adjustments to the 8-9-12 rule. However, we saw some of those percentages were pretty big. So don't be afraid to make an adjustment. And if you see an adjustment, you think the adjustment is big, just make that adjustment. It's a judgment call. It's your best guess because you're adjusting a number that's not factoring in your stacks and gaps. So if you think it's a cube, cube it. If it's not a cube, and your best guess is that it's not a cube, don't cube it. So that'll wrap up this video. The next 3 videos, the keys count.